Assalamu alaikum. I am Muhammad Ali Hassan, Senior Lecturer, Department of Mathematics, Milestone College. I hope that student you are well. I am also well. Today I will discuss about differentiation CQ-01. It's important question for your examination. So let's go look at the board. Student CQ-1. Here, function of z or f of z equals to cos 2z and g of x equals to x plus 1 by x. Question number A. Find the slope of the tangent of x square minus 2y square equals to 10 at the point minus 4, 3. Question number B. Find the value of limit h tends to 0 f of x plus h minus f of x by h. Question number C. Find the maximum and minimum value of g of x. So start now, student. Here given question number A. Question number A. Here given according to question x square minus 2y square equals to 10. X square minus 2y square equals to 10. Now differentiating with respect to x, so taking d dx of x square minus 2 is a constant, so take it to the first position of dy dx, then we get y square and d dx of 10. So student, using differentiation formula, here d dx of x square, we know that x to the power n, so take it to the first position of 2 minus 1. Again d dx of y square, so minus 2, take it to the first position of 2 minus 1. Here y is x, so again differentiating with respect to x, y. And we know that, student, using formula d dx of constant equals to 0. So d dx of 10 equals to 0. Are you clear, student? You have learned d dx of constant equals to 0. Now twice x minus 4y dy dx equals to 0. Now find the value of dy dx. So student, here minus 4y dy dx equals to minus twice x. Take it to the right side of twice x. Then dy dx equals to minus twice x by minus 4y. So dy dx equals to x by twice y. Student, here 2 and 4 cancel, minus minus cancel, so we have x by 2y. So dy dx equals to x by 2y. Then find the slope at the point minus 4, 3. So at the point at 4 minus 4, 3, then dy dx, then dy dx equals to, here putting the value of x equals to minus 4 and putting the value of y equals to 3, then we have minus 4 by 2 into 3. So 2 and 4 cancel. Here result will be dy dx equals to minus 2 by 3. So required slope equals to minus 2 by 3. So required slope equals to minus 2 by 3. So result will be slope equals to minus 2 by 3. I hope that, student, you are clear. Student, question number B. Given f of z equals to cos twice z and find the value of limit h tends to 0 f of x plus h minus f of x by h. So here given given function of z equals to cos twice z. So student, find the value of f of x plus h. So f of x plus h equals to f of x plus h equals to cos 2 into x plus h. 2 into x plus h. Putting the value of z equals to x plus h. Here z equals to x plus h. Here z equals to x plus h. So f of x plus h equals to cos twice x plus 2h. And find the value of f of x, replacing z equals to x. So cos twice x. Student, here find the value of f of x. F of x means z, replacing z equals to x, so cos twice x. Now find the value of limit h tends to 0 f of x plus h minus f of x by h. So student, given limit h tends to 0 f of x plus h minus f of x by h. Now putting the value of f of x plus h, here limit h tends to 0 f of x plus h equals to cos twice x plus 2h, twice x plus 2h. And putting the value of f of x equals to cos twice x, then h, denominator is h. Now student, using formula cos c minus cos d, here c is twice x plus h and d is twice x. You have learned, student, trigonometric formula cos c minus cos d. We know that cos c minus cos d equals to 2 sin c plus d by 2 into sin d minus c by 2. So using this formula, student, here limit h tends to 0 and 2 sin c plus d by 2. Here c is twice x plus twice x minus d is twice x by 2. c plus d by 2. Here c is twice x plus 2h and d is twice x by 2 into sin d minus c by 2. Here d is twice x minus twice x minus twice h by 2 and denominator is h. So student, attention please, here using formula cos c minus cos d, we know that cos c minus cos d equals to 2 sin c plus d by 2 into sin d minus c by 2. c plus d by 2 into sin d minus c by 2 and denominator is h. So student, here limit h tends to 0 2 sin, here 2x means 4x plus 2h by 2 and sin 2x cancel minus 2h by 2 and denominator is h. So student, take it to the first position of 2. Now limit h tends to 0 sin, taking common 2 from numerator, then we get twice x plus h by 2 and 2 cancel, so sin into minus h by h. So student, this is simplified. Now taking common 2 from numerator, then we get twice x plus h by 2 and sin minus h. So student, here 2 and 2 cancel. We know that sin minus theta equals to minus sin theta. So take it to the first position of minus. Then we have here minus 2, limit h tends to 0 sin twice x plus h and into sin h by h. So student, here minus 2 limit h tends to 0 sin twice x plus h, and limit h tends to 0 sin h by h. Here student, here separating all expression. Now putting the value of h equals to 0. So here sin twice x is h equals to, here h is 0. So we have sin twice x, and using formula, student, here using this formula, limit h tends to 0 sin h by h, this value is 1. This is formula. So here student, value of limit h tends to 0 sin h by h equals to 1. So result will be minus 2 sin twice x. So required result will be minus 2 sin twice x. I hope that student, you are clear. Question number C. Here given g of x equals to x plus 1 by x, then find the maximum and minimum value of f or g of x. Now student, given according to step, g of x equals to x plus 1 by x, equation number 1. Now differentiating with respect to x, dw2x. So ddx of g of x equals to ddx of x plus ddx of x to the power minus 1. Student, here we can write 1 by x equals to x to the power minus 1. Now we can write here ddx of g of x equals to g prime x, and ddx using formula, student, we know that ddx of x equals to 1, and now again using formula ddx of x to the power minus 1. So take it to the first position of minus 1, and here minus 1 minus 1. Now g prime x equals to 1 minus x to the power minus 2, equation number 2. So student, here one time differentiation, g prime x equals to 1 minus x to the power minus 2. Now for maximum and minimum values, for maximum and minimum values, so f prime x equals to 0. Third condition, for maximum and minimum values, f prime x equals to 0. Now find the value of f prime x, 1 minus x to the power minus 2 equals to 0. Then find the value of x. So we can write, student, here 1 equals to x to the power minus 2, or 1 equals to 1 by x square. By cross multiplication, x square equals to 1, so x equals to plus minus root over 1, so x equals to plus minus 1. So value of x equals to 1 and value of x equals to minus 1, and x equals to minus 1. So two values of x equals to 1 and x equals to minus 1. Again, student, here again from equation 2 we get, from equation 2 we get here g prime x equals to 1 minus x to the power minus 2. So find the g of double prime x, again differentiating with respect to x. So differentiating with respect to x. then d dx of g prime x equals to d dx of 1 minus d dx of x to the power minus 2. So student, we know that g prime x equals to g of double prime x, and we can write d dx using formula. Here using formula d dx of 1, d dx of constant equals to 0 and minus x to the power minus 2, so take it to the first position of minus 2, x to the power minus 2 minus 1, or g double prime x equals to minus minus will be plus x to the power minus 3. So g double prime x equals to 2 by x cube. Here 2 by x cube, it is g double prime. Now putting the value of x equals to 1 or x equals to minus 1. So student, if x equals to 1, then g of double prime x equals to 2 by 1 cube equals to 2 by 1 equals to 2. So it is greater than 0. If x equals to 1, so value of a g double prime 1 equals to g of double prime 1 equals to 2 by 1 cube equals to 2. So we know that 2 is greater than 1. Now student, here function of g of x is g of x has a minimum value at x equals to 1. I say again student, if x equals to 1, then g of double prime 1 equals to 2. 2 is greater than 0, 2 is positive, so greater than 0. Now if g of x has a minimum value at x equals to 1, so minimum value required minimum value equals to, putting the value of x equals to 1 in equation 1, so value 1 plus 1 by 1 equals to 1 plus 1 equals to 2, so required minimum value equals to 2. If x equals to minus 1, so from if g of double prime x equals to 2 by x cube, so if x equals to minus 1, if x equals to minus 1, then f double prime g of double prime minus 1 equals to 2 by minus 1 whole cube. I say again student, here g of double prime equals to g of double prime x equals to 2 by x cube. Again, if x equals to minus 1, then g double prime minus 1 equals to 2 by minus 1 whole cube. Here putting the value of x equals to minus 1 in g of double prime x, so we get 2 of minus 1 whole cube. So g of double prime minus 1 equals to 2 of minus 1 equals to minus 2. Minus 2 is negative, so less than 0. So student, we get g double prime minus 1 equals to minus 2. Minus 2 is negative, so minus 2 is less than 0. So g of x has a maximum value at x equals to minus 1. So required maximum value equals to, putting the value of x equals to minus 1 in equation 1, then we get minus 1 plus 1 by minus 1. So minus 1 minus 1. So student, minus 2. So here maximum value is minus 2 and minimum value is 2. So student, Here maximum value is minus 2 and minimum value is 2. I hope that student you are clear. Student, it's very important CQ for your examination. So see you again next class. Allah Hafiz.